Angles of elevation and depression. So your goal today, like I said, this involves SOHCAHTOA, but to be able to solve a problem that involves an angle that has elevation or depression in it. Just as a refresher, because a lot of these problems might talk about horizontal versus vertical. So how would you draw, like what's the difference horizontal, vertical? What's a horizontal line look like, Katie? Yes, horizontal. Yep, horizontal, think horizon, vertical. Okay? So, definitions, angle of elevation, angle of depression. So an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object that is above the horizontal line. Okay, so you have a horizontal line, and then say your observer is over here, the observer's line of sight to an object that is above. So this would be an angle of elevation. Okay, angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So here, let me actually, I know I drew it this way, but let me draw it this way too. If the horizontal line was dashed, and then this is the actual line of sight up to an object, because now you still have a horizontal line. I'm going to draw this dashed. But now the observer would be looking down below the horizontal line. So it'd be this angle. Okay, so when, if a problem tells you angle of elevation or depression, it's important that you're drawing the angle in the correct place. Otherwise, your whole, your work and your problem is going to be incorrect if you're not putting angle in the correct place. But I do want to say this. This shows a picture that has both an angle of elevation and depression. So notice it shows there's two people, and it shows this person here's horizontal, like the horizon in a way, if they're looking straight in front of them. Here, if they're looking up to the person up here, that's an angle of elevation. For the person up here, their horizontal line of sight is here, and they have to look down to this person, so that's where their angle of depression is. But horizontal lines, these two dashed lines here, horizontal lines are parallel. So therefore, we had talked about this briefly in one problem that was on an assignment. It was one of the problems that was on the backboard. But if these two lines are parallel, these two angles are equal. They're congruent. Angle of elevation is congruent to the angle of depression. Okay, they're congruent because this is not something that we've discussed in this class just yet, but they are alternate interior angles based on those two parallel lines. That is something we will be talking about eventually, but for now it might be helpful to know that they are congruent. Now let's actually see an example of this. So in example one, like I said, we're not only working on solving the problems, but some of these involve making a sketch. If there isn't a sketch already drawn for you, draw it out. What does this look like? So it says, Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? Okay, this is how I work through word problems because I hate hearing this, so I don't want to ever hear this. I've already heard it a lot this year, but not from you guys necessarily, from my Algebra 2 as well. Is Well, I saw a problem, it had a lot of words, so I didn't do it. And I'll ask, did you even read it? Well, no. Don't just say, well, it's a word problem. Word problems are hard. I'm not going to do it. Okay? That is the application of math. That is why you're learning math, to do these types of problem-solving problems. So read through it once, be like, whoa, that's a lot of information. I need to draw this so I can see what's actually happening. And keep in mind, we are in a chapter of right triangles. In your sketch, there should be a right triangle. You just have to figure out where that is. So it says, Leah wants to see a castle in an amusement park. She sights the top of the castle. It gives us an angle of elevation of 38 degrees. She knows the castle is 190 feet tall. And then Leah, we know, is 5.5 feet tall. We want to know how far she is from the castle. So it's also important to know what you're looking for. So if I were to draw this, I'm going to say Leah's standing somewhere over here. Okay, that's Leah. Then she's standing away from the castle. So I'm going to say the castle's over here. This is going to be my castle for right now. There's my side view of my castle, little tower. Okay, so when it says that she sights the top of the castle, I'm going back to that second sentence. She sights the top of the castle at an angle of elevation of 38 degrees. This is where you draw the angle of elevation. So you have to go off of, if she's standing there, first of all, her line of sight. That is the horizontal line. So her line of sight is here. It's not the horizontal line at the ground. This is her line of sight. And then from that line of sight to the top of the castle, that angle of elevation is 38 degrees. Okay, but now you can see here's your right triangle. Okay, your 90-degree angle is over here with the castle. Then it says she knows the castle is 190 feet tall. Okay, so I'm going to draw this over here. I know from top to bottom, this is 190 feet. However, hopefully you notice this by looking at the triangle. This side of my triangle is not 190. From here to here, that's 190. So it does give us Leah's 5.5 feet tall. So I know her height over here, this is 5.5. Okay, so how would I figure out what this is? What the side of my vertical side of my right triangle is? Okay. Yes, subtract this right here. I know this is obviously not to scale the way I drew this. This right here is Leah's height. This is 5.5. So to find this side of my right triangle, I have to take 190 and subtract 5.5. So this is actually 184.5. Okay, and then it says, how far is she from the castle to the nearest foot? So this side, this horizontal side, that length, I'm just going to call it X. That is what I'm looking for. Okay, so I have a lot of stuff drawn here. So let me do this. I'm going to draw my same triangle, but without all of the extra drawings. So I have a 38-degree angle. This vertical side is 184.5. The horizontal side is X. Okay, so this is like the problem I gave you at the start of class. We're solving for X. You just had to draw that out yourself. So we're using, like I said, we're using SOHCAHTOA. Label like your opposite, adjacent, hypotenuse. So what is the X? Opposite, adjacent, or hypotenuse? Adjacent to the 38. What is the 184.5? The opposite. So what trig function should we use? tangent. So SOHCAHTOA, we have opposite and adjacent, that is the TOA, that is tangent. So if I were to set this up, I have tangent of my angle of 38 degrees is equal to opposite over adjacent, so 184.5 over x. And I need to solve for x. How do I do that? Yep, multiply by x first, bless you. So I get x times tangent of 38 degrees equals 184.5. And then what's my last step? Yep, divide by tangent of 38. And I get x is approximately, because I'm sure I'll have to round, so 184.5 divided by tangent of 38. And make sure, again, whatever calculator you have, that you can type this in and get the correct answer. It did say round to the nearest foot, so the nearest whole number. So it would be about 236 feet. Okay, questions there? So I know I haven't graded your quizzes yet, so I'm not sure your each individual level of understanding here. If you still have questions on this part, please ask. But really, the new part today is being able to set up the triangle. This we had done before. This is more practice. Let's look at example 2. Example 2 says a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person? Okay, so you have a helicopter. So again, make a sketch, visualize this. Here's my, I'm not going to draw an actual helicopter, but I don't know, does that look like a helicopter? Sure. Okay, there's my helicopter. Oh, there's, maybe I'll do this. Don't they have a little wing? I don't know what a helicopter looks like. I don't know. I mean, I do, but I can't draw. Okay. I can draw, just not very well. I shouldn't say I can't draw. I'm not artistic. Here's my helicopter. So they are airlifting people from the scene of a boating accident. So let's say like the water's down here. Here's the water. And they observe somebody in the water in need of help. It's talking about the angle of depression from the helicopter to the person. So say there's a person here that's in the water in need of help. So you have to go off of the line of sight from the helicopter. So that would be out this way. Here's the horizontal. Then their sight to that person. Here is where the angle of depression is. That angle is 42 degrees. Okay, then it says the helicopter is 18 feet above the water. So I'm gonna just draw my triangle this way because I already have my horizontal. Here's my sight to the person. So if I were to finish off my triangle here, where would the 18 go? Which side of my triangle is the 18? Yeah, the opposite, the height. So the opposite, the 42, here's the 18. And then I'm looking for the horizontal distance from the rescuers to that person. So what side is my X? I'm going to call it X. The adjacent, X would be here. That's what I'm looking for. Okay, so there's the triangle. Okay. You could draw it the other way, like you drew it like this. Then you have to make sure, though, that you do not put the 42 here. The 42 would be here. Okay, because remember, angle of depression and elevation are congruent. So this would be the angle of elevation from the person to the helicopter. So this is the 42, not this. The 18 would be here and the X would be here. All right, so what trig function are we using? Tangent again, because we have opposite and adjacent. So tangent of 42 degrees is equal to opposite over adjacent is 18 over X. So this is now solved the same way that the warm-up was solved and the last example. So you have to multiply by X first. So X times tangent of 42 degrees equals 18. Bless you. Divide by tangent of 42. And this doesn't tell us where to round. So if it doesn't give you where to round to at least one decimal place. So don't ever round to a whole number unless it specifies a whole number. Otherwise, do at least one decimal place. So we'll do 18 divided by tangent of 42. Okay, so if I did 2 decimal places, I'd have 19.99. 1 decimal place, that would round up to 20, but it'd be 20.0. Just to show that I did round to the 10th there, or you could put 19.99. And that would be measured in feet. So either one of these is okay. Questions there? Okay, I want you in your groups, read through example 3. Your first step is to make a sketch and then to go ahead and solve. And I'll take a volunteer. I'll be walking around and I can help, but I'll take a volunteer to come up here and draw the sketch in case people are having trouble drawing the sketch. But work together in your groups to figure out how to draw this. Oh, also, if somebody is 5 feet 6 inches, what is that just in feet? 5.5. Okay, so that person is 5.5 feet tall. 6 inches is half of a foot.
So the person that's in the audience is your assuming ground.
I do.
You are assuming the person that's in the ground.
How far is Stick away. What's the difference?
You might even have to do the whole thing.
You just broke my pencil.
Yeah, we can try that. Well, the assuming the person in the audience is at ground level, so you're assuming that the stage is at their eye level. So you wouldn't have this actual measurement.
I can do my math.
What's your answer? I think you set it up. But you're not picking up the pattern, because you're looking for how far the audience member is. You're looking
I'm telling you right now. You're not reading. I made my mom mad while we were talking, and then she just interrupted our conversation and made me call her. Really? Yeah. We don't like to. She literally called my brother. I'm talking to you, and I made her mad, and she was like, I'm done.
So streamlined.
Stop giving me attitude. You can answer, so I give it back to you.
So the patterns will not be the opposite of that. The person that's 5 or 6 and look at that.
So she was like, I need to stop talking.
You're finding Is this? You're looking for the.
I was like, I might as well just leave. Like, she wouldn't even notice.
Is from the base. So then
All right, there is a sketch up here. The only thing, are you saying this, just this is 30.5?
No.
The whole thing.
I should have put the person lower, but.
That's okay. So the only thing I'm gonna change a little bit is this. Because with some of the drawings, I know it's a little different from the first one we did, if you're having trouble getting the drawing. It does say the person in the audience is at ground level. So you're kind of assuming the base of that I'm gonna switch these around. This would be, like this distance would be 25, and then your acrobat is on top, so this whole thing is 30.5. And then if you're looking for, because there was a question on this too, how far the audience member is from the base of the platform, this is what you're looking for. Okay, so if you needed help with the sketch to understand that. But otherwise, I'm going to pass out the assignment. I can check your final answer. If you have it, make sure you have it set up right.
No, I'm sick of it. You were singing, so if singing is not.
I don't.
I'm gonna do it.
I hope it is.
I'm doing it. I'm a crow. How's it on the wall? It's first time here.
No, man. It needs to stay there.
You.
It needs to stay there.
You.
Only Now it's not.
For my musical audition, I'm going to be singing a. I really was trying to sing that.
It was good. Okay. No, it's not. You did it differently. No, you're gonna have my accent Okay, well, no, fine. I was trying something before. Sure.
I really.
What?
Okay, on the assignment that you got also,
There's no.
actually just one moment here.